Hey everyone, I'm Ed Kiebler from Rottler Manufacturing. I've worked for the company for about 15 years. I've spent 47 years in this industry, loved every minute of it. I've been a gearhead since I was 14 years old, and my father gave me some awesome advice. He told me, whatever you do, enjoy what you do, and I sure have enjoyed this automotive business for 47 years and want to continue for at least a few more years. Every time I'm in a shop, my customers teach me something. So what I'm going to try to do today is maybe relay some of that information that I've learned over 47 years. So what I'm going to do today is talk a little bit about surface finish. First, I want to tell you, I am not a ring expert. I do not know, or do I care to try to estimate what rings need as far as surface finish goes. That's not my area of expertise. My area of expertise is giving you what the ring manufacturers call out for. In other words, the RPK, the RVK, and the RK parameters. If whatever you have there, I can help you get those particular numbers that you need for whatever application you're going to run. So with that said, let's get started a little bit. Probably some of the most critical things to this is your base finish. You have to determine what grit diamonds you want to start with, be it an 80 grit or a 140 grit or a 180 grit or a 270 grit, 325 grit, whatever it may be. You have to figure out where to start. And the way to do that is to look at the surface finish parameters that your ring manufacturers are asking for. And specifically, you want to look at the RVK value. So, for instance, in a blown motor or a turbocharged motor or a big nitrous motor, typical ring manufacturers, and I'm lucky enough to having dealt with Keith and Lake down at Total Seal, they've fed me a lot of information, and I learn something from those guys every day I'm around them. But they have told me that, you know, for big power applications or power adder applications, you're going to want RVK numbers 65 to 75. So those are some pretty big grooves or pretty big oil troughs in the cylinder. So what we need to do is we need to think about what that means as far as the different abrasives that we're using and actually the measurements we're taking. So I'm just going to grab something real quick over here. This is just a visual representation of what a micron is. And this is what we're going to be talking about when we're doing surface finish analysis. It's all about how many microns we're removing or how many microns of depth we have on the RVK. So this circle is representative of a human hair. And if you can see this little bitty tiny dot on the page right there, that's a micron. It's 75 times smaller than a human hair. So that kind of gives you an idea of what we're talking about. So when we're in the plateau mode, we're not taking 5/10, you know, we're not coming in with a roughing stone and then taking 5/10 out with a semi-finishing stone and another 3 or 4/10 out with a finish stone. We're talking strokes now. So we're literally, you can't measure the amount of material you're taking out in a bore when we plateau hone. And this is RVK. So if you look at this, the representation is this is an excellent plateau finish. We have very nice plateaus, a flat surface that the rings see, but we have these deep valleys that the oil is going to be retained in. And that's what we're looking for in today's motors, is we're looking for more RVK almost across the board. Again, depending on your RVK numbers is what diamond grit we're going to start with. So today we're going to play pretend and we're going to say that this LS motor is going to be a high horsepower, big turbo motor, okay? So we're going to be shooting for the 65 to 75 RVK that we're looking for. But we're also going to still be shooting for an RPK, which is what the ring sees. This is an RPK, and it's really just an RVK turned upside down, but these peaks are what you're really looking at. That's RPK count. And so what we'll do is we'll go in with a much finer abrasive over the top of this rough abrasive to give us our PK and our RK parameters. I also want to talk a little bit about, just wanted to give a shout out to the gentleman that owns this shop. This is Creason Automotive, and I'll have an assistant over here that operates a machine for me. His name is Tyler, and I just want to give a shout out to Joe Creason for allowing us to be here to shoot this video and all. By the way, just wanted to point out that these torque plates are made on the F69A Rottler block machining center. So Joe makes his torque plates on one of our machining centers. What I'm going to ask Tyler to do now is come in here, and we're going to take, and again, this is really for demonstration purposes, but we're going to take a thousandths out of each one of these cylinders, and we'll let the machine hone all we'll let it hone all 8 of these cylinders, and then we'll continue from there. So Tyler, if you don't mind, if you'd fire this thing up and remove a little bit of material. And by the way, we're using 180 grit diamonds as our base finish, and we will hone to size with those diamonds. So if I want a 4-inch, if I'm using a 4-inch 30 piston, the pistons are 4 inches 0.27, so we're going to hone right to 4-inch 30, and then we'll plateau over the top of that. So Tyler, if you don't mind. This particular machine is our H85AX, so it has hole-to-hole capabilities. So the machine will go from cylinder to cylinder without operator assistance. And then just to point out a few features, the machine has the ability to set whatever crosshatch angle you want, and that's super important on rings also. And again, your ring manufacturer will dictate crosshatch angle. I get customers that ask me constantly, what crosshatch angle should I run? And again, I refer to the ring guys. Those guys are the experts. They know what their rings need as far as crosshatch angle. But the machine makes it incredibly easy to do. It's all a matter of just typing in a number right there where it says angle. You can go anywhere from 0 or 90 degrees to almost 0 degrees, from 32 to 36 to 38 to 45. So it makes it super simple for the operator to put the exact crosshatch angle in there, and it is the same consistent crosshatch angle from the top of the cylinder through the middle and all the way to the bottom. Another feature I might point out is our rough load and finish load. This machine has the capability of actually honing to a specific load. So whatever load we set, the machine will feed the stones out to that particular load, but it won't continue to feed out. It will stop, and as the machine hones the cylinder out and the load diminishes, it will increase the stone feed up again, which is really important, especially with diamonds, because diamonds are a very tough abrasive. They take a lot of pressure to cut typically, and so we don't want to overload the cylinder. I constantly get calls from customers about my cylinders are small in the middle, so they're what we call an hourglass shape. 99.9% of the time, it's excessive load, and so what's happening is the machine is actually forcing the middle of the cylinder out instead of honing it. And so when the hone head passes through, the cylinder expands. When the hone head goes past it, it contracts again. When you take the hone head out of the cylinder, you begin to gauge it, and you're on size at the top and you're on size at the bottom, but you could be a half a thousandths tight in the middle. That's a pressure situation. And with this machine, all you have to do is reduce your roughing pressure. So right now we're running at a 40% roughing load. We may reduce that to 25% load. Depends on the block you're honing. So now what we've done is we've rough honed one bank to size. The next operation is Tyler's going to roll the block over and realign the hone head and then hit start again, and it'll hone the opposite bank. Go ahead, Tyler. There's also a graphic display on this machine, and I'm not sure you can see it in the shot, but there's a blue line here, and that blue line is pretty straight. That's telling me that we're making a very straight cylinder, less than a couple of tenths straightness. If the line were to track off this way toward the top or this way toward the bottom, if it goes this way, it tells me that we have a tight cylinder at the top, and the machine will auto-correct for that. Or if it were tight at the bottom, the machine would auto-correct for that. So people also ask me, how does it find the cylinders, or where does it know to go next? And we have a tab here called bore locations. And what we do is we center the hone head in the first bore that we want to hone. And after that, we put in our bore spacing. So this particular block is an LS block, and it's 4-inch 400 thousandths bore spacing. So all we've done is put our bore spacing for each cylinder progressing down the line. And the machine will move to that particular location and then enter the bore and begin the honing process. So another thing people constantly ask me is how do you know what size the machine is honing to? So in the first bore, what Tyler would normally do is feed his stones out to the cylinder and zero the machine, and then dial in the amount of material that he would want to take out. And the machine has a direct drive stone motor, and it has an encoder on it. So he sets however many thousandths he wants out of the cylinder, and the motor will go to that same position each time. With diamond abrasives, or metal bond abrasives I should say, they wear very, very, very slowly. In fact, in this block right here, you won't see a tenth of a thousandths difference. And once we've finished honing this, we'll grab a dial bore gauge just to show you how we've been able to hold size throughout the entire block. The other question I get is the customer says, well, my bores vary. And with standard abrasives, if you had a bore that had 3 thousandths in it and a bore that had 1 thousandths in it, you would end up with different sizes oftentimes. With the metal bond abrasives and the diamonds and the machine capability, it doesn't matter if you have 2 thousandths in one cylinder and 5 thousandths in another cylinder and thousandths in another cylinder. They will all be the same size. So our machine shut off here, and we're going to go back to the home position, and then what I'm going to get Tyler to do is change abrasives out, and we'll also throw a dial bore gauge in this in just a second here. So when we're installing the stone holders and the abrasives, it's extremely important to make sure that we reference the number on the stone holder to the number on the hone head. With super abrasives like metal bond diamonds or CBN, they develop a radius on them, and switching these around could give you a different surface finish or a different diameter. So it's real important to make sure that the number 1 on this stone holder goes into the number 1 slot on the hone head. And the same thing with 2 and 3 and 4 and so on and so forth. So we just need to make sure that we're paying close attention to that. Okay, so Tyler just changed our abrasives from a 180 grit diamond out to a 600 grit CBN, cubic boron nitride. We like CBN because it's a very sharp particle, unlike diamond, which is a very strong particle, but it's a dull particle. So when we're cutting with diamond, diamond tends to pull and tear the material more than it cuts it. And I use the analogy, if any of you have a garden and you till it up and it's real fine dirt, if you take a dull stick and pull it through the dirt, you end up with a mound of dirt on each side of the trough and a mound of dirt where the stick stops. That's a diamond. If you take a very sharp stick and you pull it through the dirt, you get much less mounding and a nice clean groove or ditch. That's a CBN abrasive. The reason that we like CBN is because it's also considered a super abrasive. So the wear factor is incredibly slow. Just to give you an idea, on a typical engine block, if you were to hone 3 thousandths out of an engine block with a standard abrasive, you're looking at about $2 a block abrasive cost. Diamond, you're looking about a nickel a block abrasive cost. So it's considerably less money to use diamond and CBN than it is to use standard abrasives, abrasive cost-wise. Now, the diamonds and the CBN are more money, and that's all figured in that price that I just gave you, $2 versus a nickel. So we've roughed it with the diamonds, and we should have some really deep RVKs, and we'll check that in just a second with our profilometer. One of the other things I did want to talk about, though, is I get customers that constantly ask me, well, if I vary the pressure, can I get more RVK? And my first answer and my answer with no explanation is no. It's not going to matter. It will matter a small amount. But with diamonds, the diamonds are in what we call a metal matrix, or a metal bond, for lack of a better term, that the diamonds are actually held in place with. And you can only have so much penetration on the diamond. The diamond is so big, and so much pressure penetrates the diamond into the cylinder wall, and then you get that metal matrix. And so it's not going to go any further by upping your pressures. So typically when a guy puts more pressure on the cylinder wall or on the honing head, all he's doing is really burning up more abrasives. It won't make a difference as far as the a higher RVK number. It might make a point or two, but not enough to really mess with, in my opinion. So I tell customers constantly, no, it's not going to make a difference. Same thing on the other side is let's say I've got too much RVK and I want to make it smaller. By lightening the pressure, will it matter? It can to a point, but again, you might vary 5 points, maybe 10 points at the most, but then you run the risk of glazing the abrasive. So what I mean by glazing is the abrasive rounds off, and as the honing process works, it's kind of like a rock in a stream. The water's rushing against the rock, and it begins to hollow out underneath the rock, okay? And the more water rushes by, it continues to hollow out until that rock finally gives way and it rolls off into another spot. That's exactly what the honing process is like. So as we're honing, the slurry and all of the pressures are eroding below that diamond, and once it gets to a point, that diamond breaks away and exposes a sharper abrasive to continue the cutting process. So if we lighten our load too much, we lose that pressure on that diamond, and so it glazes over, and we're just rubbing the cylinder is all we're doing. So yes, it will make somewhat of a difference, but then you run the risk of glazing the cylinder and not getting the surface finish that you want. Having said all that, then the only other thing I'd like to address is I get the question constantly, oil versus water-based coolants, okay? I don't know if there's a right and wrong answer. At Rottler, we recommend water-based coolants. I know the fellas at Total Seal prefer mineral-based coolants. I don't have a preference, honestly. The water-based coolants are easier as far as, you get a 5-gallon bucket, makes roughly 70 gallons of coolant. So it's real simple, doesn't cost you a lot of freight. The best thing about the water-based coolant is the cooling effect. So water pulls heat away from the cylinder walls, and you don't have the cool down effect that you will with a mineral-based coolant or oil. Oil is an insulator, so it allows the heat to stay in the cylinder, and therefore you'll have to allow it to set for an hour, maybe 2 hours, in order for it to cool down to get the true size of the cylinder. So we like water-based coolant from that perspective. The downside of water-based coolant is your gauges will get sticky, okay? And there's maintenance to it. I recommend that you check water-based coolant for the concentration level at least once a week with a refractometer. But just to kind of give you the difference between oil versus water, those are the main differences. So now what we want to do is we want to go ahead and check. This is really important when we're trying to put a plateau finish on a cylinder wall. You can't just hone it with a rough abrasive and then go in there with your 600 grit and for 5 or 10 or 6 or 8 or whatever strokes you want to go, you really need to determine the starting point. I need to know what my RVK is in this rough cylinder with this 180 grit. Now I can tell you from experience, it's probably going to be between 80 and 100 RVK. This particular profilometer is a Mitutoyo 301, so it gives me the ability to print out what the surface finish looks like and the RPK, RVK, and RK factors. And that's really what I'm doing right now. It's taking the trace, and I'm just printing out a representation of what the surface finish really looks like. So I don't know if you can see that on the camera, but you can see how rough that surface is. This being the bottom where the RVK is at, this being the peaks or where the rings will travel. So you can see there is really no plateau whatsoever on that cylinder. This is just a rough cylinder that has a RVK. Just to read them off, you won't be able to see this probably. You have an RVK of 83, an RPK of 94, and an RK of 166. So now what we'll do is we'll go in with our 600 grit CBN for a number of strokes at a prescribed pressure, and we'll see where we end up. And this is what we can vary. So depending on the RVK that we need, we can up the strokes or reduce the strokes. So it gives us the ability to adapt to the different surface finishes that we may need in a typical automotive machine shop. I'm going to explain as I go here a little bit. Normally Tyler'd be operating this thing, but I'm smart enough to push 1 or 2 buttons probably. What we're going to do is we're going to move the machine over to the locations that we need, and that happens to be number 1. And for this purpose, we're only going to hone this, we're only going to plateau this one cylinder because we want to determine where we're at as far as our plateau goes. So what I'm going to do then is I'm going to go in here and I'm going to turn off what I call my hole-to-hole automation. And it's only going to do this one particular cylinder. The other thing that I'll kind of explain is we have, and this is again a very, very important aspect of the machine when we're talking about plateau honing. You remember back early on I talked about a micron and how small it is and how little material we actually remove during the plateauing process. So if we have a machine that is rotating as the stones feed out during the plateauing process, what happens is our cylinder wall finish will be different at the top than it is at the bottom of the cylinder, and we don't want that. We want a consistent finish throughout the cylinder. So this machine has the capability. We have again another mode in this machine that says plateau. And so what we're going to do is we're going to turn that on, and instead of the hone head rotating as the abrasives feed out, the hone head will be stationary, and the abrasives will feed out several times against the cylinder wall, determine where it's at, and then begin the process all at the same time or simultaneously. And again, when we're talking about surface finish, the Brinell hardness of a block makes a huge difference. This particular block is just a OEM block, so it's not a dart, or it doesn't have dart and liners or anything like that in there, so the Brinell is much softer. So our 180 grit abrasives roughed the cylinder up considerably. You know, we were at about a 93 to 95 RVK, I believe it was, on this cylinder. So we want to get down into that 60 to 75 range for this big turbo motor. So what I'm going to do now is I'm going to wipe that cylinder out, make sure it's good and clean, because that will affect your surface finish reading. And we're using just this, what we call the right bank. That way we can see it and we're not hanging over the machine. This brings up something else that I didn't address. If you look at this sheet, you can see there's what I call an anomaly. See this divot here? That's because we've hit something with that tiny, tiny, tiny diamond stylus. And so I would probably do another, well, typically when I do this, I take at least 3 traces throughout the cylinder wall and average those, because this is not going to be exact. Again, we're talking microns. But just to give you a general idea, if you were to compare the other, you can kind of see the difference. Here we have no plateau whatsoever, and here we have a very nice flat plateau with some deep oil grooves for the RVK. Now this RVK happens to be, believe it or not, is a little bit light. So we have a 16 RPK, which is right in the middle of where we want for these high boost engines. We want anywhere from a 10 to 20 RPK. And for our RVK, again, we wanted 60 to 75. We're at 53. Okay, so our RVK was a little light on that one. We were at about 53 to 55, and we want a little bit more than that. So the way we do that is we're going to go in here, and we're going to back down on our strokes. And so we're going to take less strokes. We'll go down to 22 strokes on this particular motor just to check. Now, again, this brings up an excellent point. I am not to final size here, and that is super important, everyone. When you're doing this, you need to test this before you get to final size. So this particular motor had 10 thousandths to come out of it. We honed it to within about 5 thousandths of final size. And now we're testing our process. So when we're finished and we come up with the formula or the exact recipe that we're looking for, then we can go back in, rough hone it to size, and then come back in with the 600 grit CBN. But we know we're close, or we're in the ballpark. Now we're just fine-tuning it a bit. Okay, so if we look at this, we can see this is a much better trace than the last one. Remember that, again, what I call an anomaly or a divot? We've got a nice smooth surface all the way across. See the nice plateau with the deep scratches for our RVK? This particular one came out, this particular cylinder came out at a 12 RPK, a 64 RVK, and a 30 RK. Okay, so again, you can see the nice plateau and the deep scratches, which is our RVK. So here's a perfect example. We have a 14.5 on our RPK, which is right in the middle of our range. We have a 73 RVK now. So you could see we started out in the first cylinder, we were at 32 strokes at 25% pressure. And we were at a 54, I believe it was. The next cylinder, we went down in our pressure, or I'm sorry, we maintained our pressure, but we went down in strokes. We dropped 10 strokes. We came up 10 points on our RVK. The third cylinder, we dropped our pressure to 20%, dropped our strokes from 22 to 18, and now we're at 73 RVK. So you can see how you can adjust by strokes and pressures when you're plateauing. And again, the critical thing is to do this before you reach final size. One recipe doesn't fit everything. The dart blocks, the Darton liners, things like that with higher Brunels will take a different recipe. You may, you can start with the same roughing abrasive, but you'll take probably considerably less strokes with the CBN due to the penetration level of the diamonds. So as we wrap up, we've really talked about RVK, and we haven't talked a lot about the RPK. The RPK, as I believe I talked about, is determined by the CBN. In this particular recipe, we use 600 grit. And the reason I do that is when we have an RPK of between 10 and 20, I know that the 600 grit CBN will give us that RPK reliably, and even in the harder Brunel blocks, it'll still give us the right RPK. It may be toward the lower end of the range, but it'll still give us that. Let's say we wanted a little bit higher RPK. We wanted 15 to 20 or maybe 16 to 22. Then I might go down to a 500 grit CBN abrasive and do the very same thing. Same pressure, same amount of strokes. You may have to go a few less strokes because you have a little bit rougher abrasive, but then your RPK number will come up. No matter, the biggest misconception with fellas that are trying to do the plateau finishes is they think when they put the finished stone in and they go from 10 strokes to 20 strokes that it's going to lower their RPK number. It will not. Once you hit that base, your RPK number will not come down. It will maintain that level. So at that, if you have any questions or any comments, or I can be of any service, or, you know, just feel free to give us a call or email us, and be glad to answer them. Thanks for your time.
Watching the end of the video.
Wow, Ed, that was amazing. What a mind-blowing amount of knowledge, and thanks for the example of actually showing how to deliver those finishes. Of course, I'm Wake Speed Jr., sitting here with Ed Kiebler from Rottler. So this is our Q&A section from the honing and surface finish, putting it all together portion of the show today, which obviously we covered a lot of ground, from
yes.
You talking with Ben and Keith, talking about why we need different cylinder finishes for different applications and different ring materials. But then we got into the details of, okay, well, how do you go about achieving that? So to me, this is like really groundbreaking, because most of the things we talked about before in other seminars and things, you talk about those independently.
Right, right.
Now we kind of put it all together, and I think that's pretty groundbreaking by itself.
I agree. I think it's something that the industry has craved for quite some time.
Well, we both spend a lot of time on the road traveling, visiting different shops,
Yep.
and it's the question I get answered, or I get asked all the time. Can you answer this question? How do I get there?
Yep.
I understand I need a 50 RVK for this application. I want my peaks to be, you know, somewhere around maybe 10, 15. But how do I get there?
Yeah, how do you get there?
And of course, the question is, well, what block material do you have?
Right.
What machines do you have? What do we have? What tools do we have to work with? So, not surprising, we have a ton of questions.
That's great.
So, if you want to, we'll go ahead and dive right in.
Let's do it.
So, number one question is, do you often get different surface finish values after honing several liners from the same series, even when you're using the same honing procedure?
I would say absolutely, and I think you will agree with me there, because what happens is each cylinder liner isn't the same hardness. The material varies, and so you'll get some cylinders that are harder than another. Even in a standard V8 block, doesn't have to be a liner. Just in a V8 block, one end of the block could be harder than the other end of the block.
Well, because it's a cast material. And if anyone's ever been to a foundry or watched something on YouTube about how they make, you know, molten metal, and it's not an exact scientific process. I mean, don't get me wrong. I'm not going to knock on the foundry guys, because the metallurgists are really good, but it's not like putting in chemistry where you're getting to grams. It is chemistry, but it's pretty macro level chemistry,
yes,
not micro level chemistry. So yes, especially the more critical the application is, basically the further you climb that mountain,
yes,
the more critical those details become. A good buddy of ours we both know really well, Larry Wallace, who was another Yates protege, told me once that, you know, all the dead bodies are at the top of Mount Everest.
That's right.
Not the bottom.
Not the bottom.
because those little bit of details that don't matter so much down at the bottom of the mountain matter a lot at the top of the mountain.
Top of the mountain.
So that's the first question. Or the next question is, has anyone discussed hot honing?
I've had that question asked a lot, but Lake, you probably have better experience with that, especially being associated with the NASCAR teams and some of the other people. So I'm going to kind of
Sure.
throw it your way.
I've seen it work and not work. It is really much a mixed bag of people's opinions and experiences with hot honing. The common theme that I think I've seen over the years is that, say, a billet aluminum block engine, say pretty large bore, they'll have pretty thin sleeves. That engine will really respond in terms of blow by. Maybe not so much horsepower, but blow by, which obviously leads to, in the end, contaminating the oil and how long the engine lasts. So I think in some applications, again, billet engines, thin walls, big bores where there's a lot of movement can happen in that bore in operation, yeah, the hot honing can be something. But if you've got a really dense block with a lot of material in it that's, say, cast iron is pretty rigid, the compacted graphite blocks,
right,
they're not moving.
No.
You're just wasting your time doing that. So some guys see advantage, some guys don't. So it's definitely a mixed bag based on the application, which will be the answer to most questions, right?
Yeah,
the application dictates everything.
That's right.
we all wish there was some magic pixie dust you could dripple on things to make everything work. But it really doesn't work that way in the real world.
Yes, and especially when you're talking surface finish.
Oh, exactly. Good segue. Next question was, can you talk about Total Seal's new gas-ported ring, right here, and any honing requirements versus a standard ring? So the gas-ported ring, and you're not going to be able to see it from way over here, is, people know about a lateral gas port or a vertical gas port that you put in the piston that allows the combustion pressure to get behind the ring to push the ring out so it seals against the wall. Because it's not just the static tension of the ring that does the sealing.
That does the sealing.
It's the gas pressure behind it that does that. So when you have these gas ports in the ring, there's some pretty cool advantages, which that's a whole other topic, whole other video for that. But to answer the question directly, no. Because this ring seals so much better because of the gas ports, you don't have to change the surface finish values in order to use a ring like this. The next one was, where it was, Nicosil. That's right. Is there any precautions or thoughts about using new rings in a used Nicosil plated bore?
Again, you probably have better knowledge than I do about that. I've always been told that you want a very fine finish, typically in Nicosil. So depending on the prior finish, in other words, the old finish, you could do, if you don't have the right abrasive grit, you could really do more damage than if you were to just put that new ring in that used Nicosil cylinder.
I think that's probably the best advice, is that if you don't know, don't do anything.
Yeah.
Because Nicosil being one chemically different than cast iron, it does require a completely different surface finish. And break-in process, things like that are very different with Nicosil than cast iron. I actually have been experienced with the JGR motocross guys. Those are factory Nicosil engines from Suzuki and Yamaha. We could actually run in the same bore without rehoning it, put in ring after ring after ring, doing testing, go back to the original ring in the used bore, power numbers, blow-up numbers, the exact same as where you began. So in that case, my experience is, as long as the surface finish is right, don't touch it, let it be, because it is extremely hard. It'll last a long time, and you should be good. Other questions here. Crosshatch angle. Question about whether or not crosshatch angle matters.
Well, you're the expert in the ring end of it. You're better apt to answer that than I am.
Well, we saw the machine. Basically, you dial it in, and it gives you what you want. Getting the correct crosshatch angle with the A65A is easy.
Yes, super simple.
Now, why does it matter? Well, simply enough, it's ring rotation is influenced by crosshatch angle. You actually want the ring to rotate. Now, this guy's question was about the fact that the piston isn't moving the same velocity all the time, and that's true. But you do want the ring to rotate. It needs to rotate. Otherwise, if you stick a ring, even just a little bit micro welding, you'll see blow-by shoot up because now the ring is hydroplaning, and you don't want that. So really what you're trying to do is, the best analogy I can come up with is the further away the centers are of the crank line center and the conrod pin center, the more crosshatch angle you need. That doesn't go for everything. It's not a hard and fast, smoking unit type rule. But my experience generally is that longer that stroke of the engine is, the more those are separated, the more crosshatch angle you need to do to speed the ring rotation up. Also, as Keith mentioned, I think in the previous video, that crosshatch angle has a big impact on blow-by and how the oil travels up and down the cylinder board.
Yep.
So like a flat aircraft engine needs to have oil reach up there. So flat engines typically have a wider included angle crosshatch in order to help that oil migrate both ways. Some engines where they're trying to run a lot of vacuum, say Pro Stock motors, really flat. So different, again, application dictates what you're going to end up with.
Yep.
So one thing, again, there was a ton of questions here, and of course the iPad went dead. So yeah, it's live event, so you have to live with it, right? Things are going to happen.
Yep.
See where our other questions are coming in here. Okay, what are some common diamond grit values to have around in order to achieve the proper RPK and RVK? So if you were going to select some stones from somebody and say, here's the ones you need, what would you kind of offer up as the base to start with?
That's a great question, because obviously diamond abrasives to purchase them are more expensive than a standard abrasive. However, a diamond abrasive is
longer lasting,
and really cost per cylinder is dramatically reduced from a standard abrasive stone. But what we've come up with is we believe that the 180 grit diamond is a great base finish, and then what we do is by using a 600 grit CBN abrasive and varying the amount of strokes that we use, we can go anywhere from a naturally aspirated application all the way up to a full-blown nitrous turbo motor. So we can vary the RVKs by, probably 40, 50 points, like just by the amount of strokes we use with the CBN abrasive. So we can go anywhere from about let's say a 75 RVK all the way down to a 25 RVK.
Off the top of your head, just say for a gray cast iron, if you go in with just that 180 to start, what's that RVK going to be just as that base finish before you do anything else?
Before you do anything, you're going to be in the 90 to 120 RVK range.
See, that's perfect, because as the ring guy, right, we were talking about before, the RPK is what the ring sees. The RVK is what the oil sees. And anybody who knows anything about me knows that I spent 16 years developing, formulating, and testing oil. I kind of like the oil. That by having that base of that 95 to 100, then you can, because that 600 is going to give you the same RPK, same RK every time.
Yes.
Now you can adjust to say, oh, I only need to have an RVK of 50. I can get down there to it. But if I need to have more, I just take less away.
That's
so it's down to, I have 2 abrasives, and I can achieve the desired finish, RPK, RVK, without having to jump in between, well, I do this, and then I hold my head and scratch and itch, and then I do this next move, and which I know, that's what we know Doug was talking about before. He didn't elaborate his dad's thing, is that it took his dad 6 hours to do that block, because he was doing all these different procedures, step after step after step, to try to get to that point.
Yes.
Whereas now with diamond and a CBN, we'll call it heavy and light, you can blend to get where you want, so you can dial in that finish without having to go through a whole bunch of different processes.
That's exactly right. To go back to Robert, I know that process was either a 4 or 5 stone process.
Yeah.
You know, and it doesn't need to be. That's what we've really tried to do, is simplify things and lower the cost to the owner of the machine. And the 180 grit with the 600 grit works very well. And there's always been a misconception with the 600 grit. The more you hone, the slicker your RPK is going to get. But that's not the case. That's why we use the 600 grit CBN is that gets us in that RPK range that
right.
the ring manufacturer really wants to see. So works very well.
Well, it's going back to the Sumabore application.
Yeah, yes.
It's smooth on top, but it's got the valleys underneath. And of course, in Sumabore, it's technically not a valley, it's porosity.
It's porosity.
But it gives that, but again, that's the surface finish that we know yields the best blow by, best ring life. Everything's happy if it's smooth on top, but you're able to hold the oil
right.
for proper lubrication, as we discussed earlier in the other videos. That's the whole key, is you want to have that valley to hold the oil. You want that smooth, load-bearing surface so it doesn't wear the ring out, because we're not talking about doing chrome rings anymore.
No.
Where you need a file.
That's right. That's
to
right.
open up the chrome and make it work.
The better.
Exactly. You know, which is why the old school way worked, was because it was based around the ring materials.
Right.
And as you discussed earlier with Keith, today's modern ring materials, we have to have it different in order to have that surface finish, that ring seal soup that I would talk about.
Yeah.
Bring it all together. It's the hone, it's the oil, it's the ring, it's the pistons. That's the ring seal soup. So you got to bring it all together. And you know, there's New England clam chowder, and there's chicken noodle soup.
Chicken noodle soup.
And today's with modern rings and with modern block materials, we're cooking up some new soup.
That's right.
And you want to make sure it tastes good and it doesn't spoil and go bad.
That's right. And it's healthy.
Oh, we want that. We definitely want the healthy. So, I think that we've covered a lot of ground
yes.
here. There's a ton of questions. Hopefully we answered them, and hopefully stick around for later segments, because I know me and David Lewis are going to be back. So if we didn't
yes.
catch them now, you can catch us later. So thanks for watching this segment. We appreciate it. And
yes, thank you very much. Keep the questions coming.
Yes.
Because we will answer them all.
What a day, what a day, what a day. Yeah, my brain is swollen. I've learned so much today. They told us, don't start cars. We are not going to listen.